Okay, now I'm recording. Check the dimensional homogeneity and provide the unit for the following formula. Okay, so Ft equal to mv minus mu, where F is the force acting on an object, T is the time taken, m is the mass of the object, v is the final velocity, and u is the initial velocity of the object. Good. So this question, check the dimensional homogeneity, and then find the unit also for the following formula. Okay, so check dimensional homogeneity, meaning that we need to we need to check whether the dimension of the left hand side equal to dimension of the right hand side. Okay, so let us start with left hand side. So let's check the dimension of force time first. Okay, so force time, okay, find the formula. Force is equal to ma. Force is equal to ma, and then now we can find the dimension, but it's easier you find the unit first. So unit is equal to kilogram. Unit of this is kilogram, and then acceleration is meter per second square, and then time is second. Okay, and then so this one will become kilogram meter per second, isn't it? And then so you can find the dimension already. So the dimension of the mat will be equal to kilogram is m, mass, and then meter is length, second is time. Okay, that's the dimension of the left hand side. That's the dimension of the left hand side. Okay, now let's check the dimension of the right hand side. Let's check dimension of the right hand side. So dimension of mass and velocity actually is equal to dimension of mass, velocity. Final velocity and initial velocity is the same. So actually you must be know that this dimension is equal to mv, and then equal to like what I can say, you must treat this if you have this negative sign, means these two are separate terms. Okay, later I will write clearer for you. Okay, so change it to unit. This one is mass is kilogram, and then meter per second again, so it's the same, you see. So the dimension of the right hand side is equal to dimension of the which is this mv or mu is equal to mass lt negative 1, by referring to kilogram meter per second. So we can make a conclusion that the dimension of the force time is actually equal to dimension of mass velocity and equal to dimension of this. So which is mlt negative 1. So the unit is kilogram meter per second. Okay, so that's the answer. Okay, so is is it dimensionally homogeneous? Yes, it's dimensionally homogeneous. This equation is dimensionally homogeneous. Okay, or left and right is the same. Okay, left and right is the same. You can, it is better if you write this thing left hand side equal to right hand side. Okay, now that's the answer. Write the unit. Yeah, now this one. A force of 10 Newton acts at the origin in the direction of 40 degrees above the positive x-axis. A second force of 8 Newton acts at the origin in the direction of the negative y-axis. Find the magnitude of the horizontal component and vertical component of the resultant force. Okay, try and draw this diagram. So how many force you have? 10 Newton. This 10 Newton is 40 degree above positive x. So okay, I think we draw axis first. Yeah, let's draw an axis. Okay, okay, good. So here we have 10 Newton, 40 degree above positive axis. Okay, that's right, draw it down. Yep, this one, 10 Newton. So it is 40 degree above the positive x-axis. Positive x. A second force of 8 Newton at the origin in the direction of negative y. Okay, so I have a second force, 8 Newton, negative y. So 8 Newton, negative y. That means over here. Yeah, so 8 Newton, negative y. Okay. So let's draw. This is x, y. Okay. Negative y means going down. All right. So remember, going right positive, upward positive, left negative, down negative. Find the magnitude of the horizontal component and vertical component of the resultant force. So you need to find resultant. So find the component only, yeah, horizontal and vertical component. Good. So you have to resolve the force, class. Resolve the force. 10 Newton you need to resolve into x and y component. Then only you can combine. So this will be 10 cos 40 adjacent cos opposite sine. Yeah, so this one is this one will be 10 sine 40. Okay, 10 cos and 10 sine. So now let's finish it. So the this is all forces, so F lah, F. So put it as you can put this as F1, F2, you know. So I want to find the resultant in x component. Okay, you want the magnitude of x component. So there will be the 10 cos 40 only lah, cos 40, and then the y component is 10 sine 40, and then 8 Newton is downward, so it's negative 8. Let's check the answer, class. Check the answer, make sure it's degree, not radian. Okay, oops, times cos 40. So this one is 7.66. 7.66 Newton, and then and sine 40 minus 8 got negative 1.57 Newton. Okay, that's it. Last, you want the magnitude of horizontal and vertical component only. Yeah, he doesn't want the resultant force, he only want the component. Okay, so I got the answer. So let's check the answer, shall we? Let's check the answer. Yeah, dimensionally, the 1A dimension homogeneous, that's right. And unit kilogram meter per second, that's right. Then total fx is 7.66. Yeah, 7.66. And then total fy negative 1.57. That's right, class. Yes, so that's all for question 1. Question 2. Go for question 2. Yeah. So figure 1 shows a pathway of a bus. The bus is moving from A to B 8 meters per second for 2 seconds, then from B to C at velocity, and finally from C to D at this velocity. Calculate the distance of each pathway passed by the bus. Okay, distance, displacement. Okay, so let's do it. Yeah. Right. 2A1. So distance of each pathway. So do it each pathway, yeah, one by one. AB first. AB. Distance. So SAB will be equal to, just take the velocity multiply time. See, UT, velocity time. Okay, so 8 meter per second or SI unit, no problem. So this is a 16 meter. Then S, this one no need. Straight away like this. Simplify my work. So BC is equal to, because distance, yeah, no need direction. Scalar quantity, no direction. You don't need to say go upward, downward, to the left, to the right. No need. Distance means just magnitude. Magnitude only. Need to say direction. No need direction. Okay, so BC velocity time, so 5 times 4, 20 meter. Okay, and then finally SCD. CD is how long? 9 times 3, so 27 meter. Okay, got it. Distance for each. So now displacement. That means we don't see each pathway. We look at initial and final point. That's displacement. From we just look straight away from initial to final point in straight line. So what is the initial point? A. What is the final point? D. So this is our initial, this is our final. Go direct in straight line, shortcut. This is the displacement. Okay, so this is the displacement. So how to find this? Excuse me. So how? Okay. I better write down value I got just now, 16. is 20. Yeah, this 16, 20, and then 27. So how? Says yeah. So I can straight away actually you know. So if you look at here, I can actually the line here to here. So how big is this class? This one should be 27 minus 16 is 16 is 11, isn't it? 11. So that means uh this, this triangle, so 27. So I can find AD, right, isn't it? So Pythagoras theorem, I got AD already, the displacement. So for the displacement for AD, yeah, displacement for AD, Pythagoras, oops, correct, yeah, 20 square plus 11 square. Okay, so this one just draw it down. Okay, so check out the answer. Square plus 11 square. Third answer is 22.83. 0.83. Yeah, meter. But displacement you need to include direction. Direction. So what is the direction? So you need to give at least the theta angle. Theta. Okay. So tangent theta equal to 11 over 20. Okay, isn't it? 11 over 20. So 11 divided by 20, then antitangent. Yeah, so theta is equal to 28.81 degree. The direction it actually is 8.81 degree below positive x-axis. Yeah. Okay. Next, average speed. If we want to find average speed, then you need to average speed of the bus. That means we take the total distance, total distance divided by time taken. Okay. So find the total total distance. Total distance, you have to add up all SAB plus SBC plus SCD. So it is 16 plus 20 plus 27. So what do you get, class? 16 plus 20 plus 27. So you get 63 meter. So total distance. So average speed is total distance over time. Average speed is total distance over total time taken. Total time. So it's 63 meter divided how much time taken? The time taken is 2 plus 4 plus 3 plus 4 plus 3. 2 plus 4 plus 3, which is this is 9, isn't it? 9, yeah, 9 seconds. So yeah, 7 meter per second. That's our average speed. And then question 4, average velocity. Average velocity, is a vector quantity. So it's a total displacement over total time. Average velocity. Average velocity is a total displacement over total time taken. Total displacement. So just now displacement, take the shortcut. Take the shortcut. Total displacement is this one. 22.83. 22.83. Write it down. 22.83 meter divided by, so total time taken is 9 seconds. Let's find it. 22.83. Isn't it, class? Yeah, 22.83. So divide by 9, I got 2.54 meter per second. In what direction, class? Direction turn again, yeah. This direction also. Okay, because this is a vector quantity. Velocity is a vector. You need to give both magnitude and direction. Okay. Okay, let's check the answer, class. Yeah, let's check the answer. Is it correct? Question 2A. So 16, 20, 27. Yeah, let's check 16, 20, 27. That's right, class. Number 2, 22.83. That's right, class. 83. Okay. Then average speed 7 meter per second. Yeah, 7 meter per second. And then average velocity is 2.54. 54. Yes, that's right. Meter per second. Okay, that's right. Excuse me. Okay, now let's continue with this question B. Question B. In figure 2, a ball is thrown leftward from the left edge of the roof, a height h above the ground. The ball hits the ground 1.5 seconds later at distance 25 meters from the ground, from the building, at the angle 60 degree to the horizontal. Oh, that means hit here. The ball fall onto here. Okay, hit at 60 degree, and distance D is 25 meter. Okay, this is 25 meter from the building. Okay, so I want to find H. Okay, many things I don't know. Time taken, or given time taken 1.5 second. Yeah, so let's do it. Okay, question, yeah. So question 1. Okay, we have we have x component, y component. Okay, so first of all, what we know is ax equal to 0, ay equal to negative g. This thing you must know. Okay, time taken also given to you. Time taken 1.5 second. This one also 1.5 second. Both at the same time. All right. And SX. Okay, this one okay, tweeting direction to the left is negative. Uh Negative sign there. Let's put negative sign. So SX, put it as negative 25 because you go to the left. Yeah. SX is negative 25. SY I don't know. That's what I need to find out. Okay, and then I need to find H. I need to find H. How? Class. So let's don't talk about F. F word. Okay. Let's say I don't know U also. Just put as UX, UY. Okay. Or you can just put as UX is X is actually negative U cos theta. Yeah. Yeah. Okay. UY is negative U sine theta. Because going down, going left. That's why I got negative sign. Okay, but let's find H. H. So what I can say is this one must be equal to negative H. Sy must be negative H. So find Sy class. So right now I have this information. See that X I have quite a lot of information. So this may help us to find U, I think. Yeah. I have three information here. I can find the fourth one. Okay. So let's do it. Okay, let's do it. Let's start with X component class. S equal to ut plus half at square. So all this we put as x, ax 0. So half at square gone. Now sx is negative 25. Ux is negative. This is negative. I put just put as ux. Yeah, just put as ux. No need to change it. Just put as ux. T is T is time taken 1.5. Yeah, so I can find my ux. Okay. X, so negative 5 divided by 1.5. So is velocity is negative 16.67 meter per second. So I got my ux class. Okay. Wait. I it also give us a 60 degree, right? What can I use the 60 degree for? Yes, velocity, the final velocity. Huh? Final velocity. Okay. Fine. Uh, final velocity. So let's add one more information behind. So the one more information is the Vy, Vx and Vy. So Vx, so this point it got, going down here. That means it got two component, one x and y component. Yeah, x. So this is Vx, this is Vy. So 60 degree means here is 60 degree. Okay. So I can put as Vx is this is V lah actually. So Vx is put it as negative V cos 60. Yeah, negative V cos 60. And then Vy is negative V sine 60. Yeah. Okay, so yeah. So what can I say? Because x component is constant velocity ax0. So what I can say is no, x component in x component uh in x component you know we know that v equal to u plus at. Okay, so bx equal to ux ax. So acceleration ax got 0, so vs go to ux. Vs go to ux class. Vs go to ux. So yeah, right further. So Vx is equal to Ux. I just now I got negative 16.67. So negative 16.67 is also Vx. So Vx, I got Vx is negative V cos 60. Okay, negative V cos 60. Going to the left. Negative V cos 60. So negative 16.67. Okay. So you see that? So okay, so what is my V class? Get my V already. 16.67 divided by cos 60. So I got 33.34 per second class. Yeah, I got my V already class. I got my V. So once I got my V, I can also find my Vy. So Vy will be equal to negative 33.34 times sine 60. So it's negative 28.87. I got my this Vy also. See? Once I got my Vy, I can find my H class. Right? Find my H. I do time S equal to half. I don't have 2. 60. My U u. Let's say I ignore u. Formula do I have? V equal to u plus at, s equal to half u plus vt, equal to u plus at. Okay. E square equal to u square plus 2a. Also, I need u. What formula do I don't have to use? S equal to ut plus half at square. I still need u. So what formula? Use the u. I must use the u. So how to find h then? I have a, v. Okay. I have a, I have v, I have t. I can find my u, class. Just use this formula, class. Just use the first formula. Equal to u plus at. I got it, class. Okay, so for the y component, class, I just use v equal to u plus at first to find the u. Okay, so this is vy, uy. I need the u first. I need to find u. So my my vy just now I got negative 28.87. Okay, uy I don't know. I must find. Ay I know is ay is negative g, negative 9.81. Time taken 1.5. So I got my uy. So negative 8.87 plus 9.81, which multiply with 5. So yes, uy is negative 14.155 meter per second. Okay, I got my uy. So now I can find my h. Find my h, class. Find my h using what formula? Using which formula? Use this lah. S equal to half u plus vt. Yeah. S equal to half u plus vt. S equal to half u plus vt. Now all this using y component. Okay. Yeah. So half uy negative 14.155, vy negative 28.87 plus negative 28.87 untaken is 1.5 second. Okay, let's find out. Negative 14.15 minus 20, negative minus 8.87, okay, by 1.5 and divide by 2. Yeah, so it's sy is negative 32.27 meter. So h is actually 32.27 meter. Let's say, class, 32.27 meter. Okay, now lastly, what is the okay, got it, yeah. Now, what are the magnitude and angle relative to the horizontal for the velocity at which the ball is thrown? Okay, so want to find the initial velocity where the ball is thrown. Want to find u and theta. Yeah, find magnitude, both magnitude and direction angle. Okay, so find u and theta. Yeah. So I already have ux and uy class. Just use these two information class. Just use these two information. Okay. uh, so let's do it class. So number 2, ux and uy. So u Pythagoras magnitude of u is ux square plus uy square. That's right, yeah. So 16.67 square plus 14.155 square. So third answer, yeah, the magnitude is 21.87 meter per second. And then the direction tangent theta, yeah. Just take the just take the uy divided by ux, yeah. Uy over ux. Okay, so uy is negative 14.155, and then this is negative 16.67. Okay, so what's the theta class? 14.155 divided by 16.7. Okay, and the anti-tangent, yeah, 40.34 degree. It is thrown 40.34 degree below the negative x-axis, below negative x axis. Okay, that's it. Then do step by step. You sure can do it. Yeah. So let's check the answer, class. Let's check the answer. Question just now, that one done. Question B. 2B. 7 point oh no, this PSPM. This one B. H is 32.28. 32 is 32.8. Is it correct, class? 32.8. H. Yeah, that's right, class. I got 32.27, almost there. 32.28 the 32.27 meter. Okay, almost there. So how about velocity? 21.87. 21.87. Is it correct? Yeah, 21.87. 21.87. 21.87 meter per second. That's right. And theta is 40.31. 40.31. 40.35, 40.3, 40.34, 40.35, then below negative x-axis. 14.35. That's right. Okay, class, I got it for question 2. That's question 2. Now question 3. 3. Let's do it, class. 3. Okay, a tennis ball of mass 0.08 kilogram hits a wall at a speed of 32 meter per second and rebounds at a speed of 22 meter per second. Find the change in momentum. All right, change in momentum is actually impulse. Okay, change in momentum is actually impulse. Symbol J. So A1. So actually J is change of momentum. Okay, which is also mv minus mu. Yeah, which is also mass, can factor out v minus u. Okay, let's draw the diagram first. So this is considered the wall, and so a tennis ball is coming. Yeah, the mass is 0.08 kilogram. Okay, hits a wall, and rebound. Yeah, it's a wall. So with initial velocity, let's initial velocity is 32 and rebound. So final velocity v. You rebound now means change direction, go to the left, negative already. Negative, okay. So let's finish it. Mass is 0.08 kilogram, multiply them by velocity negative 22 minus 30 minus 30 22 minus 32. That's right. Okay, so the impulse is negative 4.32. Negative 0.32. The impulse is unit is kilogram per second. Yeah, class. That's impulse, kilogram second. Okay. But two. So find the average force on the ball if the impact lasts for this amount of time. So this is the time taken, class. So average force, that means I want to find force is actually J over time taken, the impulse over time taken. Impulse over time taken is the average force. So negative 4.32 divided by time taken 0.15 second. So divided by 0.15. Okay, so it's negative 28.8 Newton. Okay, that's right. Okay, ball. Now let's continue this one. A mass m of 5 kilograms suspended by a rope, negligible mass, length is 2 meter, force 45 Newton applied. In equilibrium, what angle theta? So this is about equilibrium, class. Equilibrium, what can you say about equilibrium? Equilibrium, that means the total force equal to 0. That means the x component, y component all equal to 0 plus. So good. So what? Okay, let's draw the forces. So this mass is, yeah, this force mg, which is 5 times g lah, because it gives you 5 kilogram. It is 2 meter ceiling. Okay, 45 Newton, a force of 45 Newton to horizontal. What angle? Okay, so what are the forces? So in a string here got tension. Okay, remember there is one more tension over here. So okay, what I can say is the force is like this. So this is the 45 Newton, and this is the mass mg, 5g. Okay, that is not salah ada theta class. So okay, so can resolve the forces class. Resolve the forces. Tension can be resolved. So this is T cos theta. This is T sine theta plus cos theta and sine theta. Yeah. Total f x is equal to 0. Yeah, fx equals 0 because it's going to the right positive, going left negative, going up positive, going down negative class. So I can write there in x component I have 45 and this one 45 minus the tension plus to the left is negative. Okay, the y component, total fy component, plus equilibrium is, that's why equal to 0. T cos theta minus mg, cos theta minus mg, which is 5g, equal to 0. Right, get theta. This one, yeah. So what can you do about this class? So I must do simultaneous class. So this one is T cos theta equal to 5 gravity, and this one is T sine theta. If go to the other side, become positive. Okay, so I have two equations. I divide them. 1/2. I got sine over cos. You get what? Tangent. 5/5g, 9.81. So I got sine over cos is tangent. Okay, let's do it. 5 divided by 5 divided by 9.81. Okay, anti-tangent. 0.91743. Anti-tangent, 40 45 44 3. Okay, let's try theta. I got it, class. Now this one, a parcel of mass 2 kilogram based on a rough inclined plane, release from rest, accelerate at a constant rate. So this acceleration, the aid of free body diagram, determine kinetic friction for the parcel. Let's draw the free body diagram. Okay. You must also slanting. You must follow the object slanting. Okay, so I have a point mass. Okay, what are the forces? Okay, first the mg, which is 2 times g. Okay, and then the 30° is the same as 30° over here. Okay, well, actually like that. So you have this mg over here. So this is 30° class. Here 30° means here is 30° like that. Yeah. Then you have the normal force class, force, then release from rest. That means it has the friction going behind, kinetic friction. Accelerate from rest, that means going down, acceleration. Like that. Yeah. So remember, for this one, we always put follow acceleration with Newton's second law. Second law, follow acceleration, positive force. Then this is the second Newton, based on Newton's second law. So follow acceleration is positive. Opposite acceleration is negative. This is for the formula total F equal to ma. Total F equal to ma. Okay. I can say put this one is positive, this one negative. Going up positive, going down. Okay, if you've got acceleration, follow acceleration. Okay, now this one must be resolved last. Resolve this force. So this one will become mg cosine 30 mg sine 30. Okay, class. What can I do now? Yeah. So what I can write here is I have component as S component and Y component. I must do them separately, class. Do them separately. Okay. So what? Okay. So in first I start with Y component. Total Fy is equal to 0 because the block is not moving in the Y component. Yeah, it's not moving is equilibrium in y component. So for Fy equal to 0, I can write the normal force, yeah, force minus mg cos 30 equal to 0. So n is equal to what's the s? S is 2 kilogram. 9.81 cosine 30. So I get what? 9.81 cosine 30. Yeah, so my normal force is 16.991 Newton. Now, as the normal force plus, I need the value. In x component, got acceleration. Got acceleration, that means total F equal to MA. Fx. Fx is MA. In y component, is 0 because no acceleration. In x component, got acceleration. Okay, so mg sine 30 is positive because follow acceleration. Friction is negative because opposite acceleration. Yeah, opposite acceleration. So I can put it this way: mg sine 30 minus friction is opposite sign equal to ma. So, and mg sine 30 minus friction is mu kn glass. Mu kn, I want to find mu k class. Find coefficient this one. Substitute all the value found earlier. I got the normal force just now from y component. S is 2. Yeah, so 2 times 9.81 sine 30 minus mu k normal force 16.991. Okay, and then S is 2. Acceleration, yeah, 4. Accelerate at constant rate 4. Can find my mu k. Times sine 30. Okay. Chewy. Okay, I got 0.10065. Yeah, that's the mu k class. Okay. Okay. Hey, is that correct class? Let's check that. So this is 3, yeah, question 3, 3A. Yeah, enter. Negative 4.32 kilogram meter per second. Yep, negative 4.2. Then number 2 is negative 28.8 Newton. 8.8. Yeah, maybe. Good, done. So question B1. 41 is 42.53. 3. 43, that's right. That is correct. 42.53. Okay. Now question B2. B2 is what? Mu k is 0.107 0.107 okay lah. 107. Okay, I done it. Question 3. So the next video will show you starting from question 4. That's all for until 1 to question 1 to question 3. Okay, thank you.